Yeah, so this is the notebook, and I'm trying to classify whether image is a slipper or others. So that is my objective. And here I had collected few data sets, and thank you all for contributing and helping me to get this data set. So just a quick peek into what exactly is our images or the training data set looks like. So yes, before going into that, I wanted to mention that I'm using FastAI is the library. So FastAI is also a company which gives us a lot of tutorials on how to learn neural networks. So I've been following that, and so this is kind of a homework which was given after lesson 1. And here we have this image data bunch. This is a function which is part of FastAI library, and I'm using from folder is the attribute. And let's jump into this particular path, and let's see how it is. So this is the path. So I have two folders over here. One is train and validate. So I'll be having all the images using which the neural net is going to be trained in this particular directory, and the valid directory will hold the images which will be used to validate the model. So just to make sure that we don't validate using the images using which we trained the model, so just to segregate those things I've done. And inside we have two folders. So these are my classes. So one, we have the slipper classes which holds all the images of slippers, and then we have others which has the which are not slippers, so sandals and shoes and etc. So this is how I'm feeding the input into the model. So I just need to, it's pretty straightforward. So I just need to pass the path into and all the rest of the things like segregating what is the class name, and which is the collection of training, and which is for the validation part. Everything is passed and taken care by this function. So this is a great thing by the FastAI people. And here even it needs to be transformed, right? So each images are of different sizes. So this function, I mean these attributes and normalize, it helps us to transform the images such that it can be fed into the neural network. So everything is done in a single line, so which is very straightforward and useful for us. So you just need to as you can see that I've just asked some of my friends to take some images, and they just shared me this, and then I just placed it kept them in two different directory, and that's all. Within a single line of code, I was able to transform them and visualize them in Jupyter Notebook. So yes, we can see the number of classes, it's slipper and others. So this is the important part. So we have the CNN learner, which is again a particular function from the FastAI. So basically it is a convolutional neural network, and I am using a ResNet, which is a pre-trained model. So we are not training any model from the scratch. So we already have a model which has been trained using millions of images, which is capable of identifying many objects. On top of that, we are going to fine-tune the same model with our data set, so such that it is capable of identifying whether it is a slipper or not. So that is the ultimate objective. So here you can see, as I had mentioned, so this is the information about the neural net. It has multiple layers, and you can see the activation function and other details. So here the fit attribute, this is the exact training process. So here I have trained the model with our data set, whatever I showed earlier. So here you can see the error rate. So this is basically something like to identify the accuracy of the model. So as the EPO count has increased, so the entire data has been trained again and again over the network, and 15% it has the model has identified, wrongly. So that means here accuracy would be 85%. So this is our this is to keep track. We can change these values and try it out. So this is to understand how accurate our model is. And then here we have to know, after this training process, we want to know what exactly happened. So for that we can use this classification interpretation, again pre-built functions from FastAI. And here you can see the images, how it has been identified. So here you can see the predicted value and slash the actual one. So most of the images have been classified correctly, predicted correctly, except these two ones. So this one has been identified as a slipper, but you can see it is not a slipper. So so this is some kind of a heat map. So heat map, you can see this pink color sparkling thing, right? So this actually helps us to tells us this information, like what exactly has the model identified or predicted. So that is why we have this heat map. If you don't want the heat map, you can just simply remove it and run it once again, so you don't see that, but we just see the images and then what it has been predicted and what exactly it is. But to debug and what if we wanted to know what exactly is happening, so that time we need to know what exactly the model has predicted. So this heat map is another handy thing which helps us to know what exactly the model has done. So yes, thank you.